All right, and we are live. Welcome everyone to the first ever demo day. So we're really excited to be showcasing the winning teams from, I think it was 2 weeks ago, Blockchain Waterloo's first ever Olympihacks held in Waterloo, Canada. So we've got 3 teams on here. We have the Interpal team, the Glue team, and the Intergalactic Pioneering with Axelar team. So super excited to have you guys on the stream to demo what you built, how you use Axelar's GMP to power your wins, and just to learn more about the projects, and hopefully inspire some other future hackers to get involved with Axelar's hackathons. So I'm going to go in order. So we're going to start with Ben and Alyssa from Interpal. Why don't you introduce yourselves?
Yeah, we also have William who's with us, but he's not physically with us, but he's on the stream as well. But yeah, so we just did Olympihacks recently, and thanks Kate for hosting the Axelar part and helping to answer our questions. Really appreciated that. It was a really great hackathon. But yeah, let's get into it. So we kind of we didn't run into Axelar for the first time here. We ran into it in Lionhack as well, but we were a little daunted because it was one of our first hackathons in blockchain. So we thought we could try to address some of these concerns like we had as hackers.
So we're going to do intros of everyone, and then we'll pass it off to the Interpal team. You guys are just so excited. It's all good. All right. Beside Interpal, we've got Chapman from Glue.
Yeah, hi everyone. So I'm Human or Chapman, whatever. I'm a master's student at Waterloo, and it was fantastic experience just being in the hackathon and just spending 3 days at the university. It was fantastic, and yeah, glad to be here and to be presenting our project.
Awesome. Next, there's William from Interpal.
Yeah, I'm a third-year computer science student at Waterloo as well. Just super excited about the blockchain space. Just recently started development actually. My first blockchain hackathon was at ETHDenver, and it's been like diving into a rabbit hole ever since.
Nice. Next, we have Adrian from Intergalactic.
Hi, yeah, I worked on the Intergalactic Pioneering with Axelar project at the Olympihacks, and it was actually myself and one other student from Michigan State, as well as we collaborated with 2 students from Waterloo, so it was a nice collaboration across the universities there.
Nice. So next we have Sean from Glue.
Hi there, this is Sean. I'm a master's student at Waterloo. Actually, that was a great experience to build Glue just in 24 hours, and we are so excited to tell you how we did that and what plan do we have for our future. Nice to be here.
Awesome. And last but not least, we have Mohammed from Glue.
Hey everyone, I'm Mohammed. I'm also a part of the Glue team. We worked on the Glue project, and it was a fantastic experience with Axelar, and we talked to Kate and Stefan in that hackathon. It was a great experience, and I would love to continue our work on Glue and present that work today. Thank you.
Awesome. So now that we've done the quick intros, now Interpal, it is your time to shine. So I'm going to remove everyone else from the stream and give you guys the floor. So.
Thank you, Kate. We were just too excited.
Yeah.
All
yeah.
Good. All good.
So yeah, backtracking a bit, the reason why we built Interpal was kind of to address our concern with like onboarding users to blockchain technology in general. And we also wanted to just learn more about Axelar when we did it. So I think the hackathon was one of the best ways we could do that. Yeah, so we in our project, we made a chatbot basically that can integrate with blockchain features like minting NFTs. And we supported several different chains to do this. And along that line, we used Axelar for general message passing in order to send tokens and update variables in different smart contracts on different chains. For example, we could use smart contract in Avalanche to communicate with a smart contract on Polygon, which is something that we thought was super cool and we couldn't really do in other using other protocols. So yeah, William actually has a demo we can jump into,
Awesome. Yeah.
just to show how that actually looks like.
Yeah, I mean, when we were judging, it was really impressive to see, the combination of AI and Axelar on the back end to make, what can be a pretty complicated user experience, developer experience, make it super simple and make it accessible for everyone, right? Like the idea of having a little widget in the corner to kind of do what you're going to demo live, simplifies it so much. So really excited to see the demo for this.
Mm-hmm.
Yeah, so I'm just playing the video demo right now. This was something that was recorded before, but yeah, that's the idea. We want to make blockchain accessible to everybody. We don't want people to have to like spend hours setting things up, having to like debug issues. Like we just want something that anybody can just like chat with and easily get into blockchain. That was our basic mission, and that's what we wanted to do through Olympihacks.
So if you want to share, so just click on the bottom console there, present, and then you can add the screen, and then I'll add it to the stream so that we can have it going. We can see it
live. Wait, can you repeat that again? Are you able to see my screen?
No, not yet. So you've got to add it to the stream. So if you just click present at the bottom there.
Present, okay.
Yeah, and then add the channel that you want to stream.
Okay. Are you able to see it now? Sharing screen, sharing this tab to StreamYard.com.
There. Yeah, awesome. So yeah, why don't you walk us through kind of a complete demo, talk about what you can do with it, and yeah, show us what you guys built.
Yeah, I guess we can start from the beginning. So our first feature was just minting NFTs across 13 different chains. So you just like give it your wallet address, give it the name you want to give the NFT, give it a description, and give it an image. So it just prompts you, and also you have 13 different chains to choose from, so you can select the chain you want, and then it will just mint the NFT for you. You don't have to do any setup, you don't have to do any coding. You just give it the information you want and it will mint an NFT. So this is a confirmation minting on Etherscan. And then if we skip forward, so that's the NFT minted, and then we'll be able to see it on OpenSeas. So these are the other NFTs we're able to mint. From Ethereum, Avalanche, Optimism, Arbitrum, Polygon. And yeah, our next feature is actually uploading files to the centralized hosts with MintBuddy. So you just select file uploading. We supported Jackal, IPFS, as well as Hedera. So we just call their APIs to upload these files. And also, if you have any questions about like which storage provider you want to use, any questions about any protocols, yeah, you can actually just type the question to the chatbot, and we actually fed in the documentation from these technologies, and it's able to generate a response based on that.
Amazing. So what AI application, or what did you use for the front end for the AI part?
Yeah, so we use OpenAI just to parse the language. And yeah, we just have an API key that we're using for this. We're using several different APIs from the different technologies we use, like Jackal Labs. We created a custom API for Axelar, which we want to get into as well. So here you can see on the screen, you can send messages and tokens cross-chain with, we rebranded as MintBuddy because we're continuing to build on it. But as Interpol, like you can also put in, if you want to do cross-chain transaction, you just write that. You can choose your first smart contract, the first chain you want to use, and the second one. William, could you actually go back a bit on the video?
Yeah, for sure.
I just want to show everyone. Right, so it's you're saying you can choose the cross-chain functions option, and then say you want to do general message passing by Axelar. And then you can select your first chain that you want to use, and then the second chain that you want the message to go toward. So here we just have a simple UI where you can press a button or you can type. So we're choosing Avalanche, and then second one is Polygon. And so we've successfully deployed the Axelar general message passing smart contracts in the background. So these are, we'll walk through the GitHub after, but we deploy these smart contracts for you. And then you put in some more details, like what message you want to send. And here it's giving you like the receipt, the Axelar scan link that shows that it's actually been done. So here it is from Avalanche to Polygon.
Nice. Nice. Yeah, this is super amazing that you were able to build it over a weekend. We were really impressed by the front end, but also the back end. So if you guys want to get into maybe some of the code, if your GitHub's public, would love if you could pull it up and
yeah, I can screen share that.
Yeah, perfect.
Okay, can you see my, oh, one sec. Okay, here we go. Can you see my screen? Okay, so yeah, this is our GitHub page, and we have a folder for Axelar. So we made a custom API. So we have both generating deposit address. So this is really useful from Axelar if you want to take out your assets from like an exchange, right? So here we're just simply defining an API where you can get the deposit address that we generate. So this would be pasted into our chatbot um, as a response to the user. So if they say like, I want to generate a deposit address, basically what happens is they can use this address. Actually have a video somewhere. But yeah, this GitHub is all available. We can share it with you guys. But what you can do is you can ask it for this address, and they'll send you the address. You just can send your tokens directly to it to deposit to any chain. That's something that's really cool from Axelar. And here are our smart contracts for the actual general message passing. So we have both a regular call contract and a call contract with token. And this smart contract we deployed.
I don't think we can see on the screen. Maybe
Oh,
you have
really?
to like change the tab.
Okay.
Do in the same tab. Yeah. Okay. This is the
Okay.
tab.
Thank you. Thank you. Yeah. So we have call contract and call contract token smart contracts. So we've deployed several of these for each different chain we have, and our chatbot can also deploy it as well. And we have it in a file called .vf. It's a special voice flow file for our machine learning integrations, which I'll show in a bit if people are interested. But yeah, this is a contract that we used. We actually took parts of it from a GitHub. So Axelar supplies some really cool tools for people who want to build, and so we just use this as a starting base. Um, we can send tokens basically using this contract. So if you deploy on Remix, for example, or you can use Truffle or other things, your own IDE, you can deploy your smart contract and you can use it with our bot. Yeah, so that's the main feature we had with Axelar, and we're able to do it with Avalanche, Polygon. We tested with Gurley, Ethereum mainnet, and some other things. And you can check for the Axelar scan link to see that it actually transacted.
Awesome. Yeah, if you want to drop the GitHub link in the chat, and also we will be publishing a blog post today on all the winners, the projects, so links to the dev post as well as the GitHub. But yeah, if you want to drop the GitHub link here in the chat, so people can go check it out. So I guess last question from my end is in terms of developer experience, right? Like developing on Axelar, kind of from zero to hero, right? Like getting into the docs, playing around with the SDK. How was that experience for you guys? It was a condensed experience because we're at Hackathon, but overall, how was building on Axelar for you guys?
Yeah, I think the documentation is one of the best in terms of Web3. The website is pretty good for devs. So if you look at the documentation is just good. Like it's structured well. We try to work with some other things in the past, just past hackathon project ideas, and they're just not as easy to work with. But I think for us, the Axelar part was more like trying to find a use case or like trying to figure out like how we should demonstrate this in the best way. And I think we got around to a pretty cool demo, right? Like we were able to showcase to people what you can do with it. So
awesome. So yeah, so just for reference, so the Interpal team were the grand prize winners at the Olympihacks hackathon. So thank you so much, guys, for the demo, for the code sharing. We'll bring you back on afterwards when we wrap up. But we're going to move on to Glue now.
Thank you so much.
Thank you so much.
All right, let's get the Glue team onto the stream. And, all right. Hey, guys.
Hey.
All right, so I'm going to pass it off to the Glue team to, intro the project that you built, do any demos, and then we can get into the back end, into the code. So take it away.
Can you see my screen?
Let me just add it in. There we go. Cool. All right, we can see your screen and you are good to go.
Okay. Okay. Can you hear me? Okay. Hello everyone. We're Gulu. We're trying to develop seamless cross-chain app development experience. Before starting our presentation, I just wanted to provide a quick introduction to our team. Our team was formed during hackathon, that you already know that. We could achieve the first place in Axelar track, and our team member that they already introduced themselves. I just want to quickly introduce them. First, I'm Taggy. I'm PhD candidate at the University of Waterloo. I'm working on privacy preserving protocols. Human is a master student and he's blockchain developer. And Mohammed is also a master student and he works on fault tolerant systems. And Sean is also a master student and he works on cross-chain personalization. So I want to start with the problem that we want to address in Glue. We have a developer, Victor. He's sometimes confused that which blockchain platform he should choose to deploy his smart contract on that blockchain. For example, Ethereum can provide a higher level of security, but it's expensive. On the other hand, Polygon is cheap, but it's not as secure as Ethereum. He was thinking it would be perfect if he could display his smart contract and deploy the cheap logics or just keeping the states on Ethereum and deploy expensive and repetitive parts on Polygon. But his question was how to sync these smart contracts. He also has potential customers that they are on Avalanche and they want to only use Avalanche and they want like to use Ethereum and Polygon. He wants to also provide service to those section of customers. After a few hours of research, he finally found a good solution for his problem, which is Axelar. He started reading the documentation. It's well documented, but it's still hard for a developer to use the APIs, and sometimes maybe it's confusing. It's time demanding, learning all the APIs and implementing the code to use those APIs. And also he's concerned about some security pitfalls that he might make a mistake in his code. So he was thinking that I wish there was an easier method for that. Yes, I think there is a need for a more user-friendly developer experience to simplify cross-chain development. I pass to Human.
Great, thank you very much. So, enter Axelar. Yeah, thank you. Basically, here's a diagram of all the things that we did and all the offerings that the Glue had. Imagine Victor. We are going to continue with Victor. Their team wants to upload a dApp, like create some dApp services. Using Glue, which is built upon Axelar, they can deploy their main contract on Ethereum. We're just going, for the sake of argument, just go with Ethereum. There is a main smart contract. Then Glue creates a Glue proxy for that specific contract. And after that, there are some Glue gateways on other chains, for example, Avalanche, Phantom, and Polygon. These gateways are built using the Axelar general message passing protocol. And yeah, this is the way that we tried dApp developers to deploy and maintain their code. And yeah, this is the first path, as denoted there. Also, there are some dApp users who want to use that dApp, which is built on Ethereum. However, they're from Avalanche or Phantom or any other chain. And this is where Glue comes in. They can interact with the gateway on their own chain, and then the gateway is connected to the proxy, and proxy knows how to call the designated function or method from the main smart contract and returns the results back to the user. So let's talk about how Glue can take cross-chain development to the next level and make it even more awesome. Basically, picture this. You have a user on Avalanche, just as before, who's itching to explore the services of an Ethereum dApp. With Glue, that user can seamlessly dive into the Ethereum ecosystem without any hassle and without the need to actually go to Ethereum. The true game changer, however, is what Glue does for dApp developers. There's no more worrying about deploying and painstaking process of maintaining smart contracts on multiple chains. Yeah, Glue swoops in, and it's just like a superhero that handles the nitty-gritty stuff for developers. After that, developers can only focus on what they do best, which is like creating dApps that delight users. And yeah, with regard to our front end and the design that we had, this is the first design that we implemented for our website. Basically, there are two components. The first one is that DApp developers can upload their code, whether in the form of a code or an address which is already deployed. And then they would be able to select the destination chains that they want their DApp or the smart contracts to be available on. And after that, simply they hit deploy. And yeah, I'll pass things to Mohammed, which is going to go through the code. Thank you.
Oh, hey. So, thank you, Human, for presenting our front end here. I will go mostly on backend. So, in order to start our work here, we forked the Axelar examples repository, and we work on this repository to build our own work. If you go through the examples that is provided in our own repository, and you can see the directory called glue. So inside the glue, you can see two main smart contracts called glue gateway and glue proxy. And one main contract was called glue hello world to just check our functionality here. So if you go through the glue proxy, you can see that it inherits from the Axelar executable. Axelar executable is a class that we inherited from, and in order to complete the functionality here, you need to override the function called execute here. This function is being called by the smart contract call from the other chains. So whenever you call these smart contract from the other chains through Axelars, this method will be called. So inside our proxy, we have a mapping from the string to address, which basically says that for each contract, we have some kind of ID, and for that ID, we have the address. So whenever the developer wants to update the code, it only needs to provide the contract address and the new contract ID and the new contract address, and we would register their code here. And whenever the gateway pass the payload, pass the function call to the proxy, we would call the actual implementation based on the latest code that is provided by the developer here. So here we basically decode the payload that is passed by the end user. We decode that and we pass it to the hello function. And the hello function basically concat the hello at the beginning of the name, and it will return it to the proxy. After getting this modified message, we will push that in the proxy to just check the correctness of our program here. So if we go to the glue gateway is also a Axelar. Let me just find it. Yeah. Glue gateway is also executable, so it also needs to override the execute function here. The main function inside the glue gateway is forward to proxy, which basically forwards everything that end user has to this function. So here we have the encoded payload. We need to pay for all the gas fees of all of these smart contract calls here in the gateway. After paying the gas fees, we would call the contracts that is deployed in the main chain here. So in the main chain, we have a proxy. That proxy has an address that is being set by some other function here. So first, we need to set the proxy address inside the gateway. After gateway knows the proxy, it can basically call this function inside the proxy. So if we go back to the proxy implementation, by calling the Axelar gateway call contract, we would call the execute function inside the proxy. So in the gateway, we call the call contract, and in the background, Axelar would take care of that and call the execute function inside the proxy for us. So by calling the call contract, we go to the proxy, and in the proxy, we call the main functionality here. So if we go through our demo here, so Axelar example basically provides, we can provide a local chains inside our local computer here. So if we go, let me just peel that first. In order to run the local chains in our local computer, we need to npm run and run start. As you can see, there are several chains that is being set up inside my local computer. We can see Moonbeam here. We can see Avalanche here. We can see Phantom, Ethereum, and also Polygon here. And inside these, after deploying all of these channels, we need to deploy our code here. So in order to deploy our code here, first we need to build the smart contract we just developed. Inside the Axelar examples, if we run npm run build, it would deploy the code. We would wait for the code to be built, and after that, we need to deploy that on all of the chains that are being set up here. So here, as you can see, we basically can simply call npm run deploy glue local. So as you can see, we have the proxy on Moonbeam, we have the proxy on Avalanche, we have the gateway on Avalanche, and also we have the glue hello world on all of the chains here. So after deploying the contracts, we need to set the proxy for gateways. Gateways should know the proxy, so we call the set proxy here. So if we take a look at this, we would see that before calling this function, the Moonbeam proxy address is null here. But after setting the proxy address, it has the Avalanche as the main proxy, and everyone knows the Avalanche as the main proxy, and it would use that as to pass the arguments to this proxy. Now that the gateways know the proxy, we can simply deploy the main code on this specific proxy. So as you can see, the proxy now know the main code. Now it's the last function that basically execute that function inside the main proxy. So as you can see, there are no messages in the proxy before calling this function. But after calling the function, we would see that it says hello StreamYard. So now gateway passed the function to the proxy. Proxy called the function inside the glue hello world. It returned and it saved it inside the proxy. And if we run this command again, we would see that we have two messages right now. So before running, it has one message, and after running this function, we have two messages, and the two messages are the same here. So if we go through our front end here, we would see that we basically can, let me just copy the glue hello world implementation. And if we go through our front end here, and we basically can upload our code, connect our wallet, and choose Phantom and Avalanche, for example, and let's deploy our code here. So by deploying a contract, we will see that main contract was deployed on Ethereum, and the glue gateway is provided are two chosen channels, and the developer can basically call these functions. Sean will go through the future work and how we want to presume our work here. Let me just mute myself.
Hi there, everyone. Thanks, Tim, for explaining like all the details that we could achieve just in 24 hours. But that wasn't all. We have like a future plan to go through Axelar virtual machine, because we understood they are working hard to bring this orchestration through the blockchain. So we are just filling out a proposal for funding to just continue this journey. And our vision is to have a versatile experience, the versatile experience that developers have on the Web 2, but in Web 3. They need log management, they need deploy status management, and some speed insights just with deploying one contract. And the whole idea is behind a dashboard that can users and developers exactly see what's happening on different chains for their contract. And an SDK, if they don't have any contract, but they want to manage just one contract on different chains, we are so excited to continue this path with Axelar, and we believe that's the future, because if we wanted to onboard lots of dev devs in blockchain, definitely we need to make it more easy and seamless for developers to deploy one contract and suddenly be across all the chains. I think that's the future, as we saw that in internet. So maybe the blockchain can be an internet here and just one contract across all the blockchains and have the seamless experience as we have in Versal or any other deployment or contract management platform before. Thank you for listening to us. And if you have like any questions, please feel free to.
Thank you very much.
Awesome. Thanks, guys. Again, really, really impressed with, with what you guys were able to build over a weekend. And, if you've been following, the audience with what Axelar's been building, this is very similar to some of the elements of the Axelar virtual machine that we're actively building out. You guys just, managed to do it in a weekend, which is awesome. So thank you so much for the demo. Really appreciate the code deep dive that you led us through. If you want to drop this way, if you want to drop the link to your GitHub in the chat here for anyone who wants to kind of read through it themselves, that'd be awesome. And like I said, we are publishing a blog post later today with the with all the links to the GitHubs and the dev post submissions. So yeah, thank you again so much. Really, really impressive. And this was Glue, our Axelar Track first prize winner. So I'm going to now pass it off to, last but certainly not least, Adrian from Intergalactic Pioneering with Axelar. So I will hand it over to you.
Yeah, hello everyone, and I do have a presentation as well to share. So let's see if we can present that. And see if this is the correct screen. Let's try the other one.
There we go. Yeah, I see that one.
All right, so the application which we created is related to intergalactic travel. And the reason we chose this theme was because of the nature of Axelar and how we get to perform transactions that go cross-chain. And we created this for the Olympihacks 2023 hackathon with Sriram and Vijay from University of Waterloo, as well as myself, Adrian, and Joe Cook from Michigan State University. And what we did here was we connected 3 technologies: Axelar, Aurora, and Near. So our goal in this project is to combine these technologies using Axelar's cross-chain GMP, or the general message passing, in order to communicate with the Near blockchain. So why is that interesting? Why is it interesting to talk to Near? Well, let me show, for example, the Axelar documentation. You can see how there's external chains that you can support on Axelar, including EVM-compatible chains and Cosmos chains. These are the 2 types of chains that can currently be integrated. And all of these chains have reason to be added. It's very useful to connect to Axelar. However, there's some chains that currently are not supported. But our team discovered a way that we can already support a new non-EVM chain and a very popular chain, which is known as Near. So Near uses WebAssembly, and people generally program in TypeScript or Rust rather than Solidity. So it's a different type of chain. But fortunately, with the release of Aurora Engine 2.9.0 very recently, we can now connect the Near blockchain. And so in order to show that off, you can see this animation here of an intergalactic cross-chain passport. And we're showing the transition from Avalanche to Axelar, Aurora, and all the way through to Near, which was not possible before we created this project. And let's go ahead and show the scenario of the passport. So the dApp that we created gives you an empty passport to start out. And you're going to interact with the UI and collect stamps as you go through these different chains. Connecting to Avalanche is a normal Web3 experience. You can use MetaMask in your browser and send a transaction to the chain. But the contract that you'll be interacting with on Avalanche then uses Axelar GMP to make a interchain or a cross-chain call all the way over to Aurora. And from there, it'll go to near. And I'll show the back end of that and how that's implemented as well. But in the end, you should expect all 4 stamps to show up on your passport. It will look, for example, like this with a completed passport. And in order to show off the call going all the way through from Avalanche to near, we want to actually do something on the near side. And so what we've done is we've used a social media platform that someone has already built on near. And this is not something that you can call using any EVM calls, using Cosmos. It's only available on near. But with our new technology, you're able to make a call and make a new social media posting from, for example, Avalanche. So let's see a demo of how that works. If you can see this new screen, I will connect to, at the beginning, the Avalanche testnet. And on this side, I'll interact with my empty passport and begin the intergalactic experience. The first thing it shows is that we're going to Avalanche, and I'll confirm the transaction as it goes to Axelar and then Aurora. So at this point, it's attempted to make an interchain call using Axelar GMP. And we can see this on the explorers. So Axelar has an explorer to show the transactions. And we can see the most recent one is currently being confirmed so that it can go through to Aurora. This front end is going to be making calls, what are view calls, which don't require a transaction, in order to see the current status of the stamps that you've collected. So at this point, this traveler has collected the Aurora stamp for making the transition over to Aurora, but still needs the near stamp to finish off their journey. And when they finish off their journey, they should be making a posting which will actually show the completed passport over on the social media platform. We can wait for this call to be approved, but luckily I've set up this traveler, you can see a few minutes ago, to have already completed their journey, and so we can skip ahead to what it will look like when a traveler completes their journey. So this person already has all their stamps, and so when we switch over to the Aurora network, we don't need to make any new transactions or calls, but we'll simply view that we now have the near stamp, and we can go and check out the posting that's been made on Near Social using this call. And you can see that it posts the completed passport. And so that's the successful call through to Near Social. And you can even see that when you look at the Near Explorer. So let's go ahead and look at Near Explorer for this Near smart contract. And this is the back end of the Near Social platform. And once this loads, you'll see that there are submit and contract Aurora, which indicates that we've been making this call from Aurora through to Near. And if you look at the payload that's been sent here, you can see how it relates to the Axelar GMP. So for example, in this data, you can read that it says Avalanche, as well as a string address. And then you can see this JSON data, which actually represents the post that's being made to the social media platform, and that's why the image then appears. And I'd also like to show you the smart contracts that are supporting this. So we can look in Remix and see 2 main contracts. One is called the home planet, and this is where you begin, and so it relates to the Avalanche side. So originally on your home planet, when you initialize the contract, you've therefore reached Avalanche. And then you can call the travel to near function, which is what our DApp calls when you interact with it. And it makes a request to your MetaMask provider to make this call using your account. You travel to near by making first the gas payment for Axelar GMP, and then you call the Axelar gateway, and you make the call to the destination chain being Aurora, and the destination address being a different contract that we've already deployed. And it has a certain payload, which is, in this case, the actual JSON of the social media post that you want to make. And you can see where this payload comes from. It actually begins with this data that's sent during the call to the Avalanche network. And what that means is that I can make an EVM chain call that will cause directly the data of the near call. And so in our application, you can see over on the Aurora side with the nearly intergalactic contract that when it handles the Axelar GMP, it will then call the near GMP, or in other words, it'll make a cross-chain call to near, basically. And the way we're doing that is actually using the Aurora SDK. So for example, this near object here is from the recently published Aurora SDK. And we're calling a certain near smart contract, we're calling a certain function, and we're passing the data all the way through from back at Avalanche. So this is the example application that we've created, and I believe we need to show off the final step of the DApp. So now you have your near stamp, and you can click here to see the social media post that's been created, and it posts the completed passport. Or perhaps we've already shown that. Regardless, this technology can be expanded to more than just this specific call right here. Actually, we have a lot of options for what we can do now that we're connected to near. And so just some examples of that. You can even make arbitrary cross-contract calls to near. You can get the two-way GMP or the equivalent of it with the asynchronous near. And then we want to make interchain tokens and interchain NFTs as well. So that's all I have. And if there's any questions, I'd be glad to answer them.
Awesome. Yeah. Thank you for this demo. And again, the deep dive into the code there. We, when you presented the plan for this on Friday, I believe, we were excited, but we're also very impressed that you guys managed to get this live over a weekend. And yeah, with this project, as with all the others, we're excited to continue to work with you guys, and to continue to build with you guys, since all of these use cases, everything that's been presented today, is super impressive. Very different every single project, but very, very relevant, and really, really great potential for each one.
Yeah, absolutely. And so the way that we were able to accomplish this in that weekend, it was largely dependent on Steven from the Axelar team, and he made some videos that's posted to their YouTube channel. So if anyone's interested in starting development on Axelar, go and check out those YouTube videos. They're great. You get a nice intro and a tutorial.
Awesome. Well, thank you for the plug. You're doing my job. All right. So I am, and yeah, we have a hackathon channel in our Discord. So we will be posting the link to this once the stream ends, as well as, as I've said before, the blog post that's going live, which will include all of the GitHub repos for all these projects. And for anyone who has questions, anyone who wants to join, hackathon in the future, you can find teammates, kind of go through past projects there. So I'm going to bring everyone else back onto the stream just to kind of wrap up. And there we go. All right. I think this is. Oh. All right. I think we've got everyone. So yeah, I wanted to say a huge thank you again for not only participating, in Axelar's track of Olympihacks, but also for joining us here today, for your awesome demos, for sharing the code. And like I said, every project is very distinct, but really, really impressed with what you guys were able to build. Really grateful, like I said, for showing us your code, for kind of giving us a under the hood glimpse into, into how you built everything. So we're just going to drop the last GitHub here in the main channel. And yeah, a huge thank you to everyone. And like you said, we'll continue the conversation on Discord and the Hackathon channel. and we're really excited to keep working with everyone to keep building out your amazing projects.
Thank you so much for giving us this opportunity to demo. This was really great.
All right.
Great.
We're gonna end
Thank you
it
very
here.
much.
Thank you.
Thank you guys so much.
Thank you.
Have a good one.
You too.